Next for our problem, the following data were recorded during tensile test of a 14 millimeter mild steel rod. The gauge length was 50 millimeters. Determine the proportional limit, Young's modulus of determine the proportional limit, modulus of elasticity, yield points, ultimate stress, and fracture strength. Dito sa problem na ito, it is most likely data interpretation. Ang given lang sa table na ito ay itong ating load and ang ating elongation. At dito natin may apply yung mga definition na nabanggit natin for the past slides and may apply natin dito siya sa pag-interpret natin ng mga data na ito. It is said na ang ating diameter is 14 millimeters and yung length ng ating material is 50 millimeters. In this data given, sabi ko ang given lang is ang load or yung ating force and yung ating elongation, we should get its yung counterpart or yung its own stress and strain nung ating mga given data. Kukunin natin yung equivalent strain, which is by this formula. This is change in length, yung kagaya ng sinabi ko sa number 4, a problem, which is final length minus original length, and unitless siya. Kaya ito. Dito sa problem na ito, ang ating strain, ang ating change in length is yung tinatawag nating elongation. This is just elongation minus the original length. And by this formula, we got this data. Itong nasa column ng strain. Ngayon, ang kukunin naman natin ay yung stress, which is just force over area. By the formula given, which is strain force over area, and ang ating unit is Newton over square millimeter. And ang area natin will be obtained by yung ating formula for circle na kagaya ng sinabi ko kanina, which is pi r squared pi. Ang ating diameter is 14 millimeters, and just by direct substitution, we could get our area for this said problem. And after we get the area, we could just use the force or the load in newtons. Alalahanin nyo, pag kayo naguguluhan sa problem, just look at the units, and we could simply know their purposes and what are the values given. Yan. By direct substitution, force over area, makukuha natin yung equivalent stresses ng ating mga data. Ngayon, nakuha na natin yung strain and stress. We should get our first na hinahanap, which is the proportional limit. Ngayon, kung titingnan natin sa problem na ito or sa ating data, we could see na yung increment between these two, let me just annotate, these two is 0.0002. And this then 0.0002. Dito din 0.0002. Dito, dito. Pero pagdating dito, naging iba na yung difference or yung increment nila. Which is, kung titingnan natin dito, yung difference din nila is bigla ring nag-iba. Which is yung parang more or less 40 yung dinadagdag dito, dito. Dito din sa part na ito, naging iba na siya. Diba? So, sa ating proportional limit, by just simply looking at the data, we could see our proportional limit is this one. Yan ang ating proportional limit. We could next our slide, and we could see our proportional limit is 246.20 megapascals. Yes. Next, ang hinahanap is modulus of elasticity. This is just basically the slope of our stress strain curve. Kumbaga, kung tayo mag-graph pa ng ating diagram, at ito yung ating stress, ito yung ating strain, this is just the measurement of the slope. Pero since na may data na tayo, we could easily get our modulus of elasticity. Kukunin lang natin yung proportional limit ng stress. 'Di ba? Ito yung ating proportional limit. And kukunin natin ito. Yung strain na counterpart ng ating stress. By getting the counterpart, our answer and by using this formula in our next slide, by the stress over the strain of our proportional limit, we could get our final answer, which is 205.2 gigapascals. Convert lang. Next is ang ating yield point. Sa ating yield point naman, when we look back dito sa ating data, makikita natin dito si 40,100 at si 41,600. Na kung nagdagdag tayo ng small amount of load, which is 1,500, nakikita na natin na nagkakameron ng drastic na pagbabago sa ating stress at sa ating strain. Yan. Nakikita natin na nagkakameron agad ng malaking pagbabago kahit konti lang yung load or yung force na nilagay natin dun sa ating material. And by definition, ang ating yield point ay yung masasabi natin kapag kagaya ng sinabi ko kanina sa ating definition, sa ating stress strain curve, na kapag itong force na ito is umabot sa yield point and inalis natin yung force, babalik siya into its original shape without deformation or any elongation at all. Ito yung, and kapag lumampas na siya ng kaunti dito sa load at kapag nagkameron siya ng lampas doon sa ating point na yon, nagkakameron na siya ng malaking effect sa ating strain. Kaya ang ating yield point is for this problem is 270.24 dito. 270 dito siya. 270.24 megapascals. Kasi 'di ba nga yung dito mga 10 lang yung nadagdag yung na stress or tsaka yung strain is kaunti lang. Then dito biglang dumami agad yung sa part na ito, biglang dumami agad yung kanyang difference or yung increment nila sa isa't isa. Next ay yung ating ultimate strength. Ngayon sinabi ko din nung sa past slides na yung ating ultimate strength, ito yung peak o yung pinakamataas na. And by just looking at the data sa ating stress dito sa row ng ating stress, is makikita natin na ito yung pinakamataas. Ito yung peak. Bumababa man siya ng konti, pero hindi na siya tumataas ng kasing taas dito. And kasi nagpatuloy pa tayo maglagay dagdag ng load dito, magpatuloy tayo nagdagdag ng load, and nandito na nga siya sa ating point, umaabot na siya dito sa ating fracture. Nasisira na siya. And by just looking at the data, ang ating ngang ultimate strength is 441.74 megapascals. And kung yung material ay nasasagad na, Siyempre ako rin. Hindi, joke lang. Hindi, by just looking at the data, we could get our fracture strength. Ngayon, kung makikita natin sa elongation, nandito na tayo sa ating fractures. And we could just simply get our counterpart o yung stress ng katapat nitong fracture na ito, which is ito, and this is our fracture strength. Our ultimate strength, 441.74 megapascal, and our rupture or fracture strength is 399.51 megapascals. Thank you.